For this problem, we are solving for the coefficient of restitution E, and we're given H0 and H2, which are the initial position of a steel ball and the final height of that steel ball on the second bounce. What we don't know is H1, but we can use the idea of H1 in that variable for a substitution and solve for the coefficient of restitution. So let us go ahead and do that now. And first we'll use the energy equation. So that is 1/2 mv squared equals mgh. M cancels out and we can solve for v, and that equals the square root of 2gh. And we know H0, H1, and H2, so we'll then get three equations from that. V0 is equal to 2gh0, V1 equals 2gh1, and V2 equals 2gh2. And the coefficient of restitution, we can get two equations from that, because V2 over V1 and V1 over V0. For this problem, we're going to ignore the x direction because we can imagine that it's just bouncing like this. But that's hard to conceptualize in a picture, so they extend it out laterally. But we really only need to worry about the y direction. So these are all the equations that we need. But we don't know anything about V1 here, or here, because we don't know anything about VH. So let's do substitution where that V1 disappears. Starting with V1 over V0, that equals 0. We get V2 over V1. And solving for V1, we get that it is the square root of V0 times V2. So if we were to substitute this V1 into this E equation, we would get E in terms of V0 and V2. And that looks like the square root of V0 times V2 all over V0. And we can simplify this equation to V squared 2 over V0. And these cancel down. So now we get a nice equation of V2 over V0. We know that V2 is equal to the square root of 2gh0, and V0 is equal to the square root of 2gh2. So we have this equation here, which can again be simplified down to h2 over h0 by canceling the 2gh, and that is to the 1/4. And if you wanted to, you could substitute the h2 and h0 values in earlier so you don't have to do this mathematical simplification, but you can find out that you have the relationship of the coefficient of restitution given h2 and h0.